Hey Cloud Gurus, welcome to another episode of Azure Service Spotlight. My name is Gwyn Peña-Siguenza, and today we're taking a look at Azure Functions, the event-driven serverless compute platform by Microsoft Azure. Serverless is all the rage these days because it allows us to develop applications without having to manage the infrastructure. And yes, servers are indeed still running your apps. Perhaps a better name would have been server maintenance-less, but that's not as catchy, so here we are. It's definitely not the perfect model for every single solution out there, but it is a great fit for many. Companies like Relativity state that they can develop solutions with Azure Functions in a week versus 4 months when they use traditional models. Now, you don't have to be a big established company to use Azure Functions. You might be looking for a platform for your next side project. And guess what? Azure Functions might be a great fit for you. Let's dive in. Azure Functions is event-driven. It'll only run when it's triggered by an event like an API call or a change in a database. As demand increases for your app, Azure Functions will match that demand with as many compute resources as necessary. As that demand decreases, those additional resources will also drop off. All of this automatically managed by the Azure platform. In terms of integration, Azure Functions has triggers and bindings. Again, triggers are what cause your functions to execute. There's a couple of options. I can name a few like HTTP trigger, webhooks, blob storage trigger, timer, RabbitMQ, etc. Bindings are a way of declaratively connecting other resources to your function. And you can use them in and out and both at the same time. Some examples include signal R, like queue messages, and a bunch more. Now you can mix and match bindings to suit your needs, and even create custom ones if you have to. If you wanted to, say, build an API, you could use an HTTP trigger to listen to HTTP requests, and pair that with a blob storage output binding to save data from the function to storage. If you need to implement patterns like function chaining or fan out and fan in, you can use durable extensions. It allows us to create stateful workflows and manages state, checkpoints, and even restarts for us. At the time of filming this video, you can develop Azure Functions in C#, F#, JavaScript, Java, PowerShell, Python, and TypeScript. The last four are only available in Azure Functions runtimes version 2 and 3. But since runtime version 1 is in maintenance mode, you're better off just using versions 2 and 3 anyways. In case you'd like to develop Azure Functions in a language that isn't officially supported, you can use something that's called custom handlers. They act as lightweight web servers and they listen to events from the function's host. And any language that can implement HTTP primitives can be used to implement custom handlers. Anthony Chu is a PM on the Azure Functions team at Microsoft, and he's been showcasing this feature a lot on Twitter. I've seen him being able to use this with Ruby and even PHP. All right, so now that you know the languages you can use, let's talk a little bit about the tooling. You can create Azure Functions in the portal, but you're better off using a couple of cross-platform tools that Azure has provided. And you might be familiar with some of these already. That would be Visual Studio, Visual Studio Code, the command line, or Azure Resource Manager templates. We'll be doing a demo in just a little bit using the Azure portal and Visual Studio Code, so you can get an idea for how these actually work. Before that, let's talk pricing. How much your function will cost depends on the hosting plan that you select. Your hosting plan will also define a couple of things: how your function app will scale, the available resources, performance, and any additional features that your function can utilize. In the consumption plan, you pay for only when your function apps are running. You are billed per million executions and gigabytes per second in memory consumed. There is a free grant that you can use across a subscription across all the functions in that subscription, and that's 1 million executions per month and 400,000 gigabytes per second of memory consumed. So that means if you stay under that free grant in terms of compute costs, you're not going to be paying anything with the consumption plan. Do keep in mind that you'll have to deal with cold starts and timeout periods. So when you are developing, you might have to work around those limitations. If you're using the consumption plan and you find that you can't deal with the cold starts, or you need to run your functions for a longer period of time than what's allowed in the consumption plan, or you need more memory options, then the premium plan might be a better fit for you. Your build per vCPU and memory consumed by your functions, and at least one instance must be active at all times. This means this will result in a minimum monthly cost, even if the functions aren't triggered at all. You do get added benefits like no cold starts, unlimited execution time, and advanced networking options. If you need to run your apps in an isolated environment or use custom images, or if you have some spare app service plan capacity, then you can use the dedicated plan. In the dedicated plan, you are charged for your Azure Functions like any other app service plan like web apps would be charged. One thing to keep in mind here is that autoscaling is handled a little differently. So if you're gonna be using this plan, make sure to look into that before. All right, let's dive into the demo. Hey Cloud Gurus, I am in the Azure portal and we're gonna go ahead and create a function app inside of the portal. So I'm gonna search for function. I've already have it in my recent services, so I'm just gonna click on it. If you have created functions before, you're gonna see a list of them in here. I've got one, but I'm gonna add a new one. Next, we're gonna define some information in here. Which subscription, this one is fine for me. Resource group, I've created one called Service Spotlight Func-Resource Group, and I'm gonna use that one. We can call this Service Spot Demo. I'm going to select code for the publish option, and the runtime stack, I'll select .NET Core. And you have a couple of other options like we mentioned. And region, I'm going to use EastUS 2. Let's click on next, hosting, and in here, first of all, it asks us, hey, which storage account do you want to use? When you are developing in the portal, you have to create a storage account alongside your function app. If you're doing this locally, you do have the option to use development storage, and you can use the storage emulator and the storage explorer, but that's not an option in the portal. Next, we select the operating system. I'm going to stick to Windows, and the hosting plan, remember we mentioned we have consumption, premium, and dedicated or app service plan. Consumption is fine here. I'm going to hit review and create, and finally, going to go ahead and create the function app. There are a couple of other options that you can change when creating your function app, but those are outside of the scope of this demo, but I do encourage you to poke around a little bit more when you are creating a function app just to see what you can change. Alrighty, so after a couple of minutes, our deployment is complete. We can go ahead and select this button, go to resource. A couple of things to note here in the overview page is the resource group that we created the function app inside of, the location, the subscription, the URL, which is the combination of the function app name, .azurewebsites.net, and app service plan, and you can actually see some metrics and such in here. Now, on the left side under functions, we're going to go ahead and select functions, and we see we have nothing in here. So when you create a function app, you're creating sort of this folder or container for as many functions as you want. So it really just creates the configuration and any helper resources that you need. And then once that's all deployed, you can go ahead and add an individual function. Here's where we are going to be able to select our development environment. We're going to do this in the portal, but we do have the option to use VS Code or any editor plus the core tools. We'll use VS Code in a minute. We're going to start in the portal. And we have to select a template to get started. Remember I mentioned every function must have only one trigger because that's how they get executed, right? So you see we have HTTP trigger, event hubs, Cosmos DB, and a couple of other options. I'm going to select HTTP trigger, scroll down a little bit more, and it asks us for the new function name and authorization level. I'm going to set this to anonymous, and we can keep the function name to the default value. Setting this to anonymous means anyone can access our function. And for the purposes of this demo, this is going to work great for us. You might want to reevaluate that in production scenarios. Alrighty, so the HTTP trigger 1 is now created, and we have an overview with some info. On the left side, under developer, we're going to click on code plus test. And in the portal, we can actually develop these functions. You will see we have some .NET code in here. If you are familiar with .NET and C#, this might look pretty straightforward to you. What's going on here is it's expecting this HTTP trigger to be executed by some HTTP request that contains a value name in it. And then it's going to give us a custom message depending on that value. So we're going to go ahead and click test and run. And you see here in the body, we can send it some JSON information. I'm going to change this to Gwyn and then hit run. We have our console down here, and we're going to be able to see any output down here as well. Alrighty, and you see that our HTTP response content says, hello Gwyn, this HTTP trigger function executed successfully. And there we go. If we make some changes to the code, for example, what if we just change this to be, hello, nice to meet ya. And then we can run this again, hit run. Oh, I forgot to change the value to Gwyn. It's probably going to say hello Azure now. Yes, hello Azure. Oh, all right. We ran into a little error here. We see that this didn't update, and that's because I forgot to hit save after applying this change in the code. So you hit save, you can see that it has to compile again. Compilation succeeded. Then we can run test run again. I'm going to change this name to Gwyn and then hit run once more. Fantastic. Now it says, hello Gwyn, nice to meet you. And right, so this may seem pretty straightforward and simple. However, this is a fully working Azure function. And though it is a very, very basic solution, we kind of got it all set up with a couple of clicks, and changing this code was optional, right? Of course, developing in the portal isn't going to be your best bet if you're working on more complex solutions and you need, certain developer tools and debugging tools and such. So now let's take a look at how we can develop using Visual Code. Alrighty, so now let's take a look at how we can create an Azure Functions using the blob trigger inside of Visual Studio Code, developing locally on your machine. So you do have to have some things installed. For example, Azure Core Tools and the Azure extension for Visual Studio Code, the Azure Functions extension. So just make sure you have all those things set up for yourself. I've got it all hooked up for myself, so I'm going to click on this Azure Functions extension on the left side, and I'm going to click on this Create New Project. I'm going to select the folder where we'll be creating this. It's on the desktop, Functions, and I'll hit Select. We'll be using C# as the language, and we can select blob trigger, but again, we have multiple options here. I'm going to keep the default values just to keep it simple. I'm going to create a new local app settings. This is where we're going to be able to have our environment settings and variables when we're developing locally. In terms of subscription, I'm going to select Gwyn's free subscription, and storage account. Because we're using the blob trigger, we do have to select a storage account, and I'll just use this one on the top. Now it's asking us the path that the function will be monitoring, and this default value is fine. I'll show you a little bit more about what this means in a minute. And now it's telling us in order to debug, we must select a storage account for internal use. And you can skip this for now and use development storage, but we can also select the storage account that we created or that we selected in the wizard a few steps ago. So I'm going to do that. And we're going to open up this project in the current window. Let's go ahead and let this create. Alrighty, so Visual Code has just finished creating the function for us. We can see that on the left side here in the file explorer, we have a .cs file, a .csproj file, a host.json, and a local.settings.json. These two, this is where the actual function is written in. You can see the code there. csproj is specific to .NET, host.json, and local.settings.json allow you to configure settings. Just keep in mind that local.settings.json will not be pushed to production because it keeps all your secrets in there. If you are using Azure Functions in production, something like Azure Key Vault is your best bet, but this is for local development only. All right, so let's open up this blob trigger C#1.cs file. And I'm going to close these panels just to gain some more space. With the goal being to keep this lesson language agnostic, I'm just going to go over the blob trigger here. You can see the things that we defined in the wizard, the path that the function will be monitoring, the connection to the storage account that we selected, and then just some variables that we can save the file once we have access to it. So I'm going to show you how this works. If we expand these two here, I'm going to head into the terminal there. And then on the left side, we're going to go to run and simply run this. That way it can be up and running and listening to any changes to the blob container inside of the storage account that it has access to. Fantastic. So we see here functions, and then we just have the one function. If we had more functions, we would see more in this list, but we only have this one. I went ahead and created inside of that storage account the blob container called samples-work items. Remember I mentioned I was going to explain this a little bit later. So essentially this is the container that we defined that we would be listening to, and the name has to match, of course. And in here I can upload a file. Since we've executed the function, it should already be listening to this. And then hit upload. Back to the terminal into the console output. And there we go. You see name, which is the screenshot, a PNG file, and then the size. And we could obviously access the content of this file, or really any file that you were to upload. And you could mix and match bindings. Say you wanted to move this to another storage account, you could use a blob trigger, a blob output binding, and then move this file somewhere, or parse this file and send it to another function as a HTTP request. Really, the possibilities are endless, but this is a really simple getting started with Azure Functions and Visual Studio Code. So what's the verdict? Let's start with the pros. With the integration options, no server patching, and auto-scaling nature that Azure Functions has, it's going to enable you to save time and cost because you'll write less code and maintain less infrastructure, making Azure Functions a prime candidate for projects big and small. And of course, the cons. With the consumption plan, you'll have to deal with cold starts and timeout periods. And if this is something you can't tolerate, you're gonna have to select a different plan. And in any other plan besides the consumption one, you're going to have a minimum monthly cost. So keep that in mind. So should you invest, evaluate, or revisit? If you're already using Azure, then Azure Functions is an absolute no-brainer. Go ahead and invest. If you're not using Azure, I would still say evaluate. There's tons of benefit and value that you can find with this serverless offering. All right, that is it. This is actually my first video on the A Cloud Guru platform. If I did well, give us a thumbs up. If I didn't do too well, cut me some slack and leave me some constructive feedback in the comments. All right, Cloud Gurus, keep being awesome, and I hope to catch you in the next Azure Service Spotlight.